Pawan, can you hear me?
Yes, sir.
Okay, fine. Okay, fine. I'll share my screen and let's begin. Sorry about my customer meeting.
No problem.
Okay. Hope you are able to see my screen.
Yes, sir.
Okay, fine. Today we will start one of the very important topic in data science, that is statistics. Okay, maybe next another 3-4 sessions. So I will be more discussing on the statistics, theoretical as well as the practical. Okay, fine. Okay, so I think this is my last, not updated. This is my old slide. Probably you know that how we come up to this, and also we covered at least 2-3 sessions on MATLAB and Seaborn visualization. After that, we are moving to the statistics part. Okay, fine. So let's discuss the concept of statistics, and let's begin, and how it is so important in the data science. So actually earlier there was no data science at all. So actually everything was the main foundational concept of statistics. Using statistics, the people used to analyze the data, concept of statistics, because the statistics begin the around the data. Okay, so now the we need to understand what is data, and already you saw this in one of the other slides. I was discussing about the data and the types of data and all that. So it would be repetitive. Let's begin with this. So let's understand what is data. Okay. Mainly the data refers to this the facts and the statistics collected together for the reference or analysis. Okay, so again this is a very generic definition. You think any scenario or any kind of environment where we actually trying to collect certain facts and the statistics about that environment. So mainly that refers to the data, and collectively that data, it is being used for mainly for the analysis perspective, because we need to understand or grasp or do certain inferences on that environment. Okay, so that is totally based on the raw data, and we go step by step by improving the raw data to more useful information by using all our the statistical and our data science tools. Okay, so mainly what we do with this data we collect and store, so that we you already know. And again, when we discuss about collect and store, automatically there are big data and all these different kind of the data science tools are available only with respect for collection and storing the data, because as you know this, the data is a very huge. It's not we are not dealing with a very small amount of data, but this is a huge amount of the data. Because right now what has become in this century, maybe in the 21st century, because right now the storage capacity, the cost of storing that, it has become very minimal. Okay, due to that, so we don't bother about the storing the data, but we bother more about how we can process the data and how we can get certain insight out of it and trying to present a useful information, so that that can helpful for our business decisions. Okay, so that becomes very important for us. We don't bother about storage capacity because that has got a very minimal cost now. Okay, and there are various the tools and techniques involved for only for the collection and the storage of the data. For example, if you take the kind of storage, if I can speak about Hadoop and maybe on the SDFS, okay, the Hadoop distributed file system. Okay, the pig hive, there are many other kind of tools. Okay, and it has got its own the pros and cons. Probably I would take another separate sessions on especially on this collectively talking discussing about the SDFS mainly on and how we'll perform this the processing of the data using SDFS maybe with this map reduce. Okay, so this collectively these two things we call it as a Hadoop, and how it works, what is the architecture of that, and probably taking certain few examples. Probably I will cover up if maybe the time permits. Okay, and using this data, we try to measure this as we already know this how what are the kind of measurements we have for the data in terms of bits, nibble, and all that. Okay, gigabytes, terabytes. And we you have some all the soft skills for analysis purpose and also for visualization that we discussed. There are many tools, okay, like for example even the Tableau or so mean the demanding like, okay, so even the Power BI is one of the important tool. Okay, so even if you take the here maybe a little bit of MS SQL I try to cover here, okay, based on the time. Okay, then here under the visualization, the Tableau and the Power BI, we'll see that. However, how the time permits, I'll try to cover a few of the important, at least one or two classes I can cover up on that. Okay, then let's begin with what type of data is available. As you know, this the data is there, but still we need to classify that what kind of data is available. In the one of the earlier slide, you might be knowing I was giving an example for the types of data, mainly on the qualitative and the quantitative. Okay, now if you take a simple the kind of object like the oil paint. Okay, this would be a very good example actually. The if you have the oil paint as an object, now if I want to list out certain kind of data out of it. Okay, mainly what happens, so what is the measurement of the frame and what is the cost of the frame, so these are all become the numeric data. Okay, so when it comes to numeric data, so that becomes you are trying to inference the quantitative. Okay, but how about the qualitative, because you are trying to describe the particular object in terms of your natural language. Okay, so mainly with this we try to difference the data in two types kind. One is the qualitative and one more is a quantitative. Okay, under the qualitative again we have the nominal and the ordinal, and in the quantitative you have a discrete and the continuous. Okay, so for example, now if you take this in the quantitative, now the cost of the painting is around, let's say that is around $20. Okay, so if the data is in the kind of float, okay, where at any moment of the time, when if you take this time perspective, any moment of the time, if we have a data, for example, now you take, I'm collecting the weather data. Okay, in the weather data, at any moment of time, at any fraction of second, I have a data for that particular object, that is my weather. Okay, now this becomes my continuous data. Okay, and at any moment of, for example, now if you take the pressure or any kind of the continuous data, so that we call as a continuous. Otherwise the discrete is something which is always discontinuous. Okay, so that we call as a discrete. I'll come back to this definitions. And similarly in the qualitative you have a nominal and ordinal. So in the nominal, what does it mean? So when there is no order in the data, for example, if you take the sex is like a male and female. Actually if you take this, there is no order between the male and female data. Okay, means that they are equal. So if you take something like performance of a student. Okay, so he could be like the failure state, or he could be an average or more average or beyond, maybe a distinction, or because there is certain order is here. Okay, so it has got each and every value in this particular variable has got certain meaning to that. Okay, it means that there is an inbuilt order is available within this kind of variable, so that falls under the ordinal. Okay, but I cannot equate all they are same, like how I am doing it for the male and female. But here there is certain order existing in the data itself. That is the reason we call it an ordinal. Okay, so let's go into the more detailing here. Okay, so in the qualitative data, so there are, as I said, there is a nominal and ordinal. Okay, and mainly this qualitative data deals with the characteristics and descriptors that can't easily measured but can be observed subjectively. Okay, okay, fine. So here data with no inherent order. As we said, the male and female for the gender. Okay, so there is no inherent order here, and they are all equated as the same data, so that is we call as a nominal data. But when it comes to ordinal, the same example for the customer ID, okay, there's a rating is available like good, average and bad. If you take this, I cannot equate all them as the same, but actually there is a difference between a good and a bad. Okay, and good could be having the high preference compared to the bad. Okay, so means that there is certain order is existing, and that is hidden in the data itself. That is the reason we call such data as the ordinal data. Okay, next is the qualitative one. So here we have the discrete and the continuous data. Okay, and again, as I said earlier also, the quantity data mainly deals with the numbers and the things which we can measure them. Okay, objectively we can measure that. Okay, for example, as I said, this is your frame, and I can say the frame is very beautiful, but that is the kind of language I am trying to describe it, but that is done through the your qualitative measurement. But here I need to measure this. I need to tell some cost, or what is the size of this, or in terms of the square centimeter or square foot, right? So that is a measurable thing, which I can measure it objectively. Okay, for example, now if you take the discrete data, so number of students in a class, so that is a discrete value. What about the continuous data, the weight of a person? What happens at every instant of a movement, we have a data for the continuous data, as but not it's same as a discrete data. Even if you pictorially, if you represent a difference between the discrete and the continuous data, if you have studied about the maybe mm, in the signals and system that we come back in electronics. Okay, so any kind of signals is are nothing but the data, so that has the time domain. Okay, so for example, now you take certain signal here. Okay, okay, fine. Now this is your continuous data. But if I want to make it a discrete data, what we generally do that we sample this, okay, on certain time, and we sample and we collectively trying to describe this data, something like now this will become my discrete data. Okay, if you can see this, this will be around T1, T2, T3, T4, and this will be a continuous in the time domain. Okay, so that is the difference between a continuous signal and the discrete signal. But the same the same theory or the same concept holds good for our data also, the discrete data and the continuous data. And let's begin with what is statistics in general. Okay, the statistics, again, it's a very broad term. Okay, so this is not coming from now, it's thousand years before we have been using the statistics. Okay, and again, this is again a part of, and it's a branch of applied mathematics, and it is mainly concerned with the important thing is data collection, analysis, interpretation, and the presentation. Okay, so mainly is data collection is one part, analysis, interpretation, and P, presentation. We can make this as a the C, so it will become CAIP. Okay, so the definition holds good. CAIP for collection of the data, for analysis of the data, for the interpretation. Means that once we collect the data, we are going to analyze it. Once we analyze it, we want to interpret, means we want to conclude something on the data. Once we have a conclusion on the data, we want to present it to the user or whoever is requesting for the analysis. Okay, the CAIP, something like CAP, you can remember. Okay, okay, fine. Now if you take an example, how company has created a new drug that may cure cancer. For example, you think that you are working in some pharmacy company, and maybe in the COVID time, the people were coming up with a vaccine. Okay, and this vaccine, when you produce it, that cannot be tested for the complete population that exists in India. Suppose, for example, now I'll take the zone as a India. Okay, which I cannot do it. It's impossible also. So in that case, what we do actually, we take this vaccine and try to collect certain samples of the people, and we try to give this, inject this vaccine, and study in the closed environment. Okay, so I don't call it a closed environment. This we can call always an experiment domain. Okay, so under this experiment domain, what we do, we completely uh, run this experiment and analyze how actually this is going to perform. Okay, so in this kind of the mainly on the data analysis. Okay, so the statistics holds good. Okay, that's what we are trying to say. And this whole the complete picture of statistics, okay, so mainly because of we apply the experiment on the sample, then we try our best to generalize it for the population. This is very simple. So what we understand from this is there are only two things what we have to remember. There is a sample and there is a population. We perform experiment on the sample and we generalize our results for the population. What do you mean by generalization? We inference. Okay, we try to create the inference for the population and how best we can do it. So that's what, how strongly we collect the sample and how nicely we collect the sample from the population. Okay, and our statistics should be such that we need to equate between a sample and a population. And uh, that cannot be, but still what happens, we have to come up with a result such that we can generalize for the population. That's what our concept of statistics come into the picture. Okay, and this is also the same example what I'm trying to give it for the drug. We have a drug and we cannot completely test it for the complete population. We test it for a sample and we generalize the results for the complete the population. Okay, similarly what happened during in the COVID time, the India probably they came up with certain vaccines. They tested it. Okay, and also they had given a lot of the information like how this was tested and in a closed environment, and then they started generalizing it for. Okay, and probably what happens once there is any pros and cons, anything like that seen in the population, then again they will go back and retest it on the different sample, then again they will fix it and they will come back. So again this is all continuous process what they generally do it. And this is where actually our statistics come into picture. Okay, similarly, I take another example. For example, your friend is at a basketball game, and out of the blue, he offers a bet neither team will hit home run in the game. Like for example, in the even if you can take the example of the cricket also. Okay, there are a lot of betting will happen during the cricket. Okay, and this betting is not just a random, right? So again there is a statistics is involved into it, like we are going to predict based on the past data and performance of each of the individual players, and we try to predict something from the older data, and based on the statistics only we'll be able to do that. Then if you take the sales data, like your boss wants you to prepare a report for the management where the company would improve its business. Okay, so they are asking you to prepare certain kind of report for where passed on the past sales data, and you want to showcase something right now. See, we have a data science and we'll be able to do that best. Okay, on top of the statistic there are many tools, but with collectively only with the statistics also we'll be able to do that. Okay, that's what so these kind of various kind of applications which we come across for the statistics. And let's get into this basic terminologies in the statistics. Okay, basically what kind of terminology we come across. Okay, so already I told you and gave simple example on a sample and a population. And see this is the population. Okay, and this is your sample. Means that population is a huge. Okay, from that you collect certain sample and perform a statistics on this, and you try to conclude something on this. Okay, so if you take the population uh, definition, it is a collection or a set of individuals or objects or events whose property are to be analyzed, because I want to analyze it for the population, but I don't have that data. Complete data is not available. Okay, so in order to do this, I have a sample. I can always run my statistical tools on the sample, and I need to extend my definition of the statistic to the population. So this is what we can do. Okay, so that's because this is the very easiest method which I can do, but we cannot reach to the reality, but still there is an assumption that we are tending towards the fact. Okay, we are tending towards the population, but still there are a lot of assumptions and we consider certain errors. Only that we need to minimize that error and improve our statistical figures. Okay, so that's what we want to do it in statistics. Fine. Now let's go with a little more deeper in the sample and the population. Now you take this. So this is a huge data. What is available with this? Now this is my assumption. This is my population now. How do you define the population if you take it? Okay, so for example, the complete population I can definitely represent it the number in, like the what is the count. For example, if you take the COVID vaccine, now I want to give it for the whole India. Now I have a complete population, the number count. Then also I have the mean value for that, and I have a standard deviation. Okay, and using only these figures, okay, only having these parameters, actually I can define the complete population distribution, how it actually looks. Okay, so now these values, what are the number n, the mean mu, and the standard of deviation. Okay, collectively what I call them as a population parameters. Okay, just remember we call them as a population parameters. And these are the things actually I want to, or you want to, as a statistician, want to predict the about the population. Okay, this is what actually we are interested, but we cannot get it. But there is, we should always have an alternative way of doing it. By what we have to do in that case, so we need to draw a certain random sample from the population. Then for the population we don't call it as a parameter. Okay, so now what has happened now in this, these are random samples. For example, now if I take this a COVID vaccine, you can think that from the different state or a district I'm trying to pick one person, and collectively I create a sample and I'm going to apply my vaccine here. Okay, so you can just think of like this. Okay, in that case, earlier in this population I had n as my total count, and mu as my mean, and this was my standard of deviation. Okay, but when you take it a sample, this n will become small n here, and the mean will be something like this. Then standard of deviation will be s. Okay, so this is a very, this holds good everywhere. Okay, in all the publication, the papers, these symbols remain the same. Okay, whenever they refer it for a mu, it is there counting it for the population and not for the sample. Okay, the sample mean is always referred as x bar. Okay, fine. Next, what you do, the population and the mean mu. Okay, fine. Does mu is equal to x bar? That is a question, whether x bar is equal to your mu, because this is indicates your population and this indicates your sample. Obviously no, not possible actually, but we can only tend towards it. Means that tending towards the mu, that's what we can do. Okay, so probably not, we need to confident that x bar does not do, does a good job of representing mu. That's what we need to come up with. How much confidently you're saying that our x bar is representing mu. Okay, so what kind of statistics are you supporting for this x bar? That's what is complete study on statistics. Okay, and that's what I'm trying to showcase here. Okay, fine. So here, this slide is very important actually. That's what, as earlier I told you, that what is your intention of the whole statistics is that now you have a population parameter and you have a statistics for the sample. Okay, here I call it as a parameters. Here I call it as a statistics. Okay, here we have n, here you have mu, and here you have the standard of deviation. Here you have n, here for x bar, and this is your s. Okay, fine. Let's take, I am going to analyze for the mean value. Okay, if my, that is my condition, so what happens here? Obviously your population parameter, something like mu, will be equal to x bar. Okay, but as we know that we cannot do this. Okay, but still what happens, there could be a plus or additional an error, and this formula holds good for us. Okay, this is what we need to understand, and this is what we need to derive actually when we are dealing with our analysis. Okay, in that case, what happens when you consider this as a mean? Okay, and what will be your error? Error is the variation of the component by the sample size of the component. Okay, so what is the variation in the data? So that variation is nothing but your standard of deviation. Yes. Okay, so what is the standard of deviation? Actually, it says that how much you are deviating from the mean. Suppose this is a mean value and this is how your distribution looks like, and the standard of deviation is S, means that how much we are going to deviate from the mean. That's what it's going to tell us. Okay, so when you have the yes, when you divide this by square root of n minus 1, so now this will be our statistical error, that is random sampling error. And if we can come up with plus or minus to this, and hopefully we'll be equating that mu with the x bar. Okay, so that is what the understanding of this complete when you are trying to connect the population mean with the sample mean. Okay, and understand this particular slide is very important. And again, this one I have just given the example only for the mean. Okay, so even I have some proportion is there, then I have a count is there. Okay, there are different there are approaches which I can connect the population to the sample. Okay, and I'm just giving an example for the mean here. Okay, and when you derive it, this is what we need to find out and equate the mainly the population parameter with the statistical parameter. Okay, then what is sampling? Okay, again, already we discussed about this, but still with respect to the theoretical part, sampling again is a process of statistical analysis. Sampling is a process in statistical analysis. Okay, where what researcher take the predefined number of observation from the larger population. This we already, by looking at this figure, this very understood that from the population we are selecting certain random samples and creating a sample. Okay, and this happens for under the statistical analysis when we want to perform a statistical analysis. Okay, and this sampling allows researcher to conduct studies about the large group by using a small proportion of portion. So that is the intention here. Okay, then when you're saying about the sampling, so are we selecting it random, or is there any particular the methodology, or there is a particular method or any kind of approach is available with us? Yes, of course. See, there are multiple approaches to create a sample, but each approach has its own the pros and cons. Okay, and again that depends on what type of problem are you solving. Uh, Based on that, we are going to create a sampling. Okay, for example, now in the sampling we divide them broadly at the we do probability sampling and the non-probability sampling. Okay, in the probability sampling, most of the time we deal with the probability sampling and technical field. Okay, so we come up with a random sampling, then systematic sampling, and a stratified sampling. Okay, and again these are more non-probability, and again they have their own way of creating a sample. Probably I will touch upon that. Okay, but more interestingly, we need to more understand on how we come up with a random, systematic, and the stratified. Okay, as the name indicates, random, systematic, and stratified. Random means we are going with a random sampling. Systematic, probably there could be some process. Just I'm giving a glimpse idea, like by the words. Systematic means there could be certain process. Systematically, I'm creating a sample. And a stratified means probably I'm stratified. You can call it a struts. Struts means like it's there are groups. Probably from the population we create certain groups. From each group we are going to collect certain individual the members of the group and create a sample. For example, now overall from the India, I want to create a sample for testing the COVID vaccine, means probably I'm selecting one member from each district. Okay, it understood that I'm trying to cover the entire country with a different kind of environment. If that is my thinking, what I'm doing, I'm creating a different groups across the districts of the India, and from each district I'm collecting one person as a for the sample. Okay, so this indicates that I'm creating the struts. Struts are nothing but the clusters. Okay, from each cluster I'm selecting one person. Probably that's the meaning of stratified. I'll come back. Okay, fine. Now let's go with this random sampling. What do you mean by random sampling? Okay, each member of the population has an equal chance of being selected in the sample. Means that now in the whole population, okay, there are n count, okay, and what is the chance of selecting probability, okay, what is the probability of choosing, means that every member has got a equal probability, okay. For example, think that there are 1,000 members are in this population, and the chance of picking each member will be 1 by 1,000, okay. That is a probability, that will be around 0.001, okay. So this is the probability for picking each individual, means there are no higher probability or there is no low probability, everyone has a equal probability, okay. So that's what in the random sampling that happens, okay. Then in the systematic sampling, what happens in systematic sampling, every nth record is chosen from the population, okay, every nth record. For example, now you take this I'm just in a whole population, as I told you, there are 1,000 members are there, okay, in 1,000 members are there, and what I will do, I will just arrange all these 1,000 people in a row, okay. Maybe I want to pick every fifth person for the sample, means that I am doing certain systematic way, okay. So this is this kind of the approach, okay, that we call as a system sampling or systematic sampling. Then in the stratified sampling, as I earlier explained, okay, so here stratum is a, as I told you, stratum is a subset of the population, okay, that shares the least one common characteristics in this gender. For example, now you take, what does it mean is that here you have a population and this population involves the male and female. That is the characteristics of this population, okay. So similarly, I'll give one more example with respect to the COVID only. Now think that I want to test a vaccine. I want to test a vaccine for, think that for 100 parameters. What are the 100 parameters? Probably one parameter could be I want to check this for a complete healthy person at the age of 60. And I want to check this vaccine for a person having something like a sugar, okay, maybe around 45 age. I want to test this vaccine probably who is having certain BP at the age of 40. Okay. What are these? These are the characteristics of the population. But what happens? I want to consider at least one characteristics when I want to build my sample. Okay. And I want to consider all these 100. Probably you think that there are crores of people in India. Okay. And there are 100 parameters which I want to test. If I want to make 10,000 as my sample, then I want to consider all these 100 parameters to exist in my sample. In order to do this, what I will do, from this 10,000, I'll just create one stratum for each of the characteristics. Okay. Similarly, what I'm doing it for male and female also, there are only two things are here. That is the reason I have two stratum. And from this male, I will create two people. And from female, I will select two people and create my sample. Similarly, when I create the stratum for healthy, sugar, BP, from each two or three people, I'll pick it and create a sample. Okay. So that's what is the stratified sampling. And again, there could be a combination here. Maybe in the stratified sampling, I may use the random sampling also. Okay. So for example, once I create a stratum, maybe think that certain records exist here. Okay. For example, here, this is my stratum. And when I'm trying to pick these two people, okay, so I can go with a random sampling, means that every individual has got the equal opportunity to select it. Okay. So this is a mixture of both random sampling and stratified sampling. Okay. Yeah. And the types of statistics. Okay, fine. So let's begin with see, when we talk about the statistics, and the statistics, you already know by this time, you might have learned the what is the objective of the statistics, what we want to do. Any statistician, okay, any statistician, we need to understand only these. To explain this, you need to understand only the what is population, what is sample, what are parameters, what are statistics, okay, and what is the relation and what is the objective of the overall sampling it. Okay, so this whole picture will completely answer the statistics. Okay, and now when we want to do this, we need to have certain methods. Okay, so to describe and learn about the data or learn about the population what we have. Okay, in that case, so there are two classify them as, one is a descriptive statistics and one more is a inferential statistics. Okay, so this is called a descriptive statistics and the inferential statistics. Now we'll touch upon what is descriptive statistics. Fine. The descriptive statistics uses the data to provide a description of the population, either through the numeric calculations or a graphs or tables. Okay, as I told you, we want to provide and understand statistics about the population. Okay, fine. Okay, so when we want to do this in the descriptive statistics, what is the approach? Okay, for example, now you take, now there is a class of 30 students, and if I ask you, like, for example, with respect to the performance of the student, probably what you will do, so you will just give the summary out of the students, like what is the performance of the class. For example, you may give the what is the minimum score and what is the maximum score and what is the average performance of the students. Okay, what is the context here? The context is a score. Okay, similarly, and this by having these three data, the minimum, the maximum and the average, for the context, I completely understood about my data. Okay, I just completely understood about my data with the minimum, what is the maximum and what is the average. Okay, now even if you take this, for example, this is the t-shirt. Okay, and if I want to uh, created t-shirts for the group. Okay, so mainly what I have to understand, what is the minimum and what is the maximum size and what should be my average. Okay, if I know these three things, I can come up with my plan. Okay, so means that I will be able to describe my population with these important values. That's what we want to say. Okay, then what about the inferential statistics? Inferential statistics, it actually makes the inferences and predictions about the population based on a sample of a data taken from the population in the question. Okay, so now we described about the data. That means that we described about the population. Okay, we are trying to do the descriptive statistics here. Then we have a sample which is taken from the population. This is my sample. Now, what is our objective? When I do a statistics on the sample, I want to do a inferential, means that I want to generalize what I have found for a sample towards the population. Okay, so that's what makes the inferences and the predictions about a population based on the sample of data taken from the population in question. Okay, so example, now as a COVID vaccine, I have taken and have tested for a couple of people. Then I want to go and do an inference saying that this can be definitely giving certain percentage of accuracy. I can say that this can be applied for the complete Indian population with so and so result. Okay, now I want to do this. Okay, this is how it can be done. We cannot say anything like random, right? So we have to have the statistical figures for that, and this is how actually it looks like. It's not something like we create some vaccine and we want to apply to everyone. It's not like that. Okay, so completely a statistical inferences with a very strong inference is available with the government, and they are able to do this. They are not just like randomly they create a vaccine and apply it to the whole population. Okay, yeah. Okay, this is about the inferential statistics. Okay, we'll come into the detailing part. Now let's go with the descriptive statistics. Let's see what we'll do in the descriptive statistics. Fine. Descriptive statistics. Here, the descriptive statistics is a method, okay, used to describe and understand the future of a specific data by giving the short summaries about the sample and the measure of the data. As I told you, we are trying to describe the whole group of population. Okay, means a population is there. I'm trying to describe with certain measures or by giving certain statistical figures. Okay, so what we want to do, how we want to do it, how we want to describe the completed data, what is the method is available with this. So we go with the two things. Okay, means that once we have a data, for example, now you think that I have certain data here. Okay, this is my distribution of the data. This is how it looks like. To understand this data, I can do it only with the two things. One is how much how much this data is around the mean. Okay, that's one thing. And how much this data is variable. This is the measures of central tendency. Then the measures of variability. These are only things which I want to understand. Okay, means if I if I can get the glimpse of how the data is distributed around the center, then I can purely say that I can really understand that how the data is distributed. Suppose if the data is distributed very scatter, it means that there is no relation exist in the data itself. Means that from one to one, that particular relationship doesn't exist. Okay, so this scattered data will indicate the measures of variability, how much the data is varying. Okay, now what kind of the measures are available within this central tendency and the measures of variability. Let's do get into it. Okay, now the descriptive statistics, as we already know this. Okay, I just explained what we are trying to do. We are going to describe the data from the perspective of certain measurements. Okay, so in the measures of central tendency, what we have in the measures of center, three important things we have. One is the mean, and one more is a median, and one more is a mode. Okay, and we know already from the college we have done all this averaging nothing but the mean value. But what about the median, what about the mode, why we have three, and in what conditions we need to consider all of the three. Actually, i- from the statistical point of view, from the analysis point of view, it is always good that you consider all the three, and based on the situation you need to inference certain the conclusion on the data based on these three measurements. Okay, and in the measures of variability, what we have, there is a range. Okay, what it means range, it's very simple. Okay, means that you have a minimum and you have a maximum, and the difference indicates your range. Means that how much data is variable, we can in a one with a very vague understanding. For example, what is the range of the weight of the students in your class? Okay, probably in the class, probably the age might be around 45 kg to the around 90 kg is there. Okay, almost there is a range of 45 kg. This is the range of weight actually, that how actually the data varies in that range. I can definitely say this. What about, let's get into little more the interquartile range. Okay, this we can talk about. Then there is a variance, then there is a standard of deviation. Okay, yeah, let's get into it. Now the measures of central tendency. Let's get into the example, then we discuss about how we calculate the mean, median, and the mode. Here I have a simple data set of a cars. There is a collection of the data for the cars, and what are its attributes? Okay, fine. What are the attributes? There are, the car model is available with me, and the mileage per gallon, which is actually a float value. Then there is a cylinder type. Okay, there is a cylinder type. Then there is a displacement of the engine. Then horsepower and the real axle ratio current draft. Okay, so all, if you see this, except the model, all are of type numeric. Okay, good. Now, if I want to take the I want to understand the mean. Okay, the measures the average of all the values in a sample. Now this is my sample, right? This is my sample. Let's get into, okay, let's, I want to take a horsepower. What is a horsepower here? So this is my horsepower, and I want to understand what is the mean value of it. So in order to do that, what I will do, I will take the summation of all that, then divide it by the total count. So this is what I get. And you know already how to take the average. Okay. And this is one value. And we can say this, if you have a data and you have calculated the mean, one thing is that you cannot write always at the center. Okay. It depends on the kind of values that exist between r- the record. Okay. Suppose if there is a, the larger values are available here, there are smaller available here. Okay, so maybe the mean won't come exactly in between. Probably it may deviate somewhere here or here. Okay, depending on what type of variable we have. It means that that is trending towards the minimum, or this guy trending towards the larger. From this, what we can understand, the mean actually will not give the right figure for you. Means that exactly what could be your the central value of the complete your data set. Okay, so that may get influenced by your the high values, means the bigger numbers. Okay, fine. Now, if you take the median, measures the central value of the sample set is called a median. Okay, the same thing, but the central value of the sample set. How we can do this? Again, this is very simple. What we do generally, we just put everything in ascending order. We put everything. For example, now if you take this here, what I have taken MPEG. Okay, so find out the value of the cars like ascending order, then 21, 21.3. So this is that is mileage per gallon. Okay, this time I'm calculating for a mileage per gallon. I'll just put it. So if you take this 1, 2, 3, 4, 5, 6, 7 and 8. Okay, now what I will do, I will take the center numbers, that is 22.8 and 23. If you take 8, so 8 by 2 is around 4. Okay, so 1, 2, 3, 4, 4 and 5 I will take it. So leaving 3 here, leaving 3 this side. So now this I will take the average. Now 22.9 is my median. This is how we calculate the median. Okay. Then what about the mode? Mode is again very simple. Like in the case of a cylinder, you take this 6, 6, 6, 6. How many 6 are there? 1, 2, 3, 4. Here one more 5 is there. Now the most common type of cylinder among the population of the cars, okay, which is more repetitive. Okay, so that we call as a mode. Means that the count of that value is more in that record, so that takes the mode. Okay, and again one more problem is there. For example, you think so there is 1, 2, 3, 4, 5 records is there. What about 4? 1, 2, 3. Now if I add one more 2 rows to it, okay, which are having 4. Now what will happen? Both are equal now. In that case, what happens? This will become my bimodal data. Bimodal means that there are two mode in this. Okay. Okay, fine. Okay, let's understand. Now we gone through this. What is mean? We gone through what is median, and we gone through what is
Hi,
mode.
sir.
Hello. Yeah. Tell me.
Sir, when it come the bimodal data, which will be the mode values?
Yeah, I'll take that separate. Okay, so because all three, I need to discuss about the pros and cons in the lab. I'll take it. Okay.
Oh,
Okay. So because what happens in the bimodal, when you plot that, probably there will be two counts. For example, now if I take this as a count and this is my bar plot. Okay, now think that this is also 6, this is also 6, everything somewhere here. Now this will become my bimodal data. Okay, so but we cannot only depend on the only one type of central tendency. It is always good that we need to consider the mean and the median for our analysis. Getting my point? Okay, it's not just that we have to always focus on the mean. It's not never. Okay, you need to calculate mean, median, and the mode. Based on that three figures, we need to inference out of that. Okay, how actually what kind of data is that? Means what kind of distribution is that? Getting my point? Okay, fine. Now mean, if you take this, defined as the arithmetic average of all the observation in the data set. Okay, so mean, median, and the mode. In the case of median, what is the advantage is that here this is an average of all the observation, as I told. The median is again when you put up a ascending order, and in between two the values middle one you take and you create decide that that is a median. In the case of mode, the number of frequency of occurring of that particular observation, you consider that. Okay, and if you take in the mean, one thing is that in the mean it consider all the observations, but in the median and the mode it does not consider. Okay, because in the mode we just count, we consider only the most frequent, but we don't bother about what other data exists with us. Okay, and also in the median also we don't consider about what other data is existing, but we try to just go with the middle numbers, because ascending order that could be low or very high, but those end data or in between we never consider, we just go with only the middle one. Okay, so again it has got its own pros and cons, okay, that we can discuss. And this uniquely and comprehensively defined, yes, okay, this is uniquely defined, and this cannot be uniquely determined under the conditions, and this can be always changing. For example, now you take the mean value, uh, this is certain my sample for the mean I have taken from the population. What I expect is that if this is my population and this is my sample, as a statistician, what is the observation is that, see, this sample what I take it, this has should have be in accordance with the population, the distribution. Okay, it should be in accordance with the population. Okay, and a light variation is acceptable. Okay, so means that it has got certain mean and standard of deviation. Maybe this could be a little changes should be there, but I this is acceptable for the sample. And there is one more sample which I have taken somewhere. Okay, even I expect the same thing, it has should, but when I mix up these two, when I mix up these two, still this is my sample, but in that case my mean will remain the same, but this median and mode will change. Okay, so that cannot be uniquely determined under certain conditions. Okay, that's what I'm saying. Then mean is, of course, these are extreme values it is affected. That's why what we do generally, we try to normalize the data, means we standardize it. That we'll discuss when we are doing the pre-processing part, which we call as a normalization or standardization of the data, so that we put the everything in data under between certain range. Okay, and so that any of the higher order data would not affect my the analysis. Okay, fine. So that's all about the mean, median, and the mode. And again, this can be treated algebraically. Here they cannot be treated algebraically. Okay, that's what mainly with respect to the calculation. That's what he's saying. Okay, yeah, that's about. Okay, let me check the time. Okay, this is okay, fine. The measures of spread. I think this will I will take it. Okay, fine. I think uh yeah, this one I will cover up with the lab tomorrow. Okay. This okay, fine. Pawan, any questions now?
No questions, sir.
Okay, till up to now it's fine, na? Okay,
Fine, sir.
okay, fine. Then now what we'll do? The next thing uh, we can discuss about. Okay, 1 second. Okay, so this will give just give idea on how do you deal with the statistics. Okay, but this is again purely on the descriptive statistics. But more important is that inferential statistics. Okay, so that that time, yeah, we need to get a very good knowledge there. Okay, so maybe if you have very strong and you start speaking more on those vocabulary of statistics in any of the interview, right? So it's understood that it's by default that the person is aware about the data science. Okay, Pawan, I tell you, keep reading, and improve your vocabulary with respect to the data science, especially on the statistics. Okay. Okay, fine.
Can you provide sir the documents?
Documents, you need to create your own documents, Pawan. Okay. See, you need to read the blogs. Okay. That I will give it with respect to the labs. Okay. For example, now you take uh, today I want to discuss this. Okay, so descriptive statistics. I've created all that. Okay, for example, the table of contents, whatever I have covered, measure of central tendency, measure of description with the definition, everything I've written it very well. Okay, so this actually I had given some, I had someone had given an assignment for me, and I had done that. Okay, so maybe I'll share with you. Fine. Okay, everything neatly was done. Okay, just go through that, and also had given my conclusions on the day, what kind of data it looks like. Hmm? See, generally what happens when you start working, right, you need to create your own documents because that is your understanding. Generally what I generally follow is that is my habit. Okay, so for example, now you think this. Okay, I'll keep reading things, and I will create my own documents. Even if you take these data science ML documents. Okay, so I keep reading things, and I will create my own documents. Okay, because these are my documents, and I'll be knowing that what I have written, and I'll be knowing more easily, and I will keep updating those documents also. Okay, getting my point? So you need to create that habit. Instead of me giving a document, you read it. It's better that you create your own documents for that particular, because you know that a lots of blogs are available. Getting my point?
Yes.
Now, if for example you take this uh, Google, I'll just give a very basic idea. Think that take this one only. See, just it's my blog. Okay, what it explains about to get an understanding on correlation, autocorrelation, and partial correlation. Okay, so this particular the content what you write it, no, so this content will be generated by you based on your experiment. Okay, like I'm just trying to explain in the 5 steps to understand what is correlation, autocorrelation, and partial correlation. So when you begin with, I just describe about what is univariate descriptive statistics. Okay, so in this statistics, I was explaining about so what kind of statistics is available with us. Okay, so this is done with one of the tool. Okay, so once we do this, then I explained about the what is ACF, autocorrelation function. But there are many ready-made functions are available. But is it possible that we can do it with the Excel sheet? If you do this, the formulas you replicate it in the Excel, means that you'll get a very good understanding on how actually the formulas are working. Okay, so this is not easy to understand until and unless you actually do it exercise by yourself. Okay, then the compute, how you compute the ACF, and what are the steps I have taken to do this. Then covariance function is very important when I'm doing it for the partial correlation. Okay, then that PS, partial autocorrelation functions. And I'll tell you this particular thing to get an understanding itself is it can you have to make your hands dirty into those concepts of statistics, then only you will be able to come up with this. Okay, and that's what I'm saying. Just documents will not help. You need to create your own content. Getting my point? You are there or left?
Yeah, yes, sir.
Okay, now you take this. I had written one a long back. Okay, maybe in the 2020 I had written this one article, Introduction to Machine Learning and Design of a Learning System. Okay, see, for a even for a vague person also will very much get an understanding on this. Okay, see here I just I give one example because that time my son was maybe less than 1 year old, almost around 4 years he was there. Now my son Siddharth is 4 years and we are working parents. We always wanted to take care of him without the help of daycare or crunch. With this constraint, anyone has to be available at home to take care. When I used to be there at home, I had a big confusion to understand why he cries. The reason could be feeling hungry, feeling thirsty, feeling irritation due to the clothes or due to anything, etc. I think it is a very common to any parents. Okay, so there see to get an understanding of the machine learning, it's very important when you get into real problems. Okay, now you think that mm, in the daycare, right, in the daycare you can get lot of kids. If you get the kind of data, if you can generate the data, something like a baby cries, the crying waves for at least for 2 or 3 minutes. Okay, and you need to label it that why he's crying, probably because of the wet cloths or probably because of the hungry, all that. See, for each and every label of the data, the wave file will be different. Getting my point? Now from the wave file you can always extract the features out of it. Okay, now that will become your pure supervised learning. Now what you have to do, you come up with your AI technique and build a model for the kids actually. Okay, and if you can embed that into any of the device, something like think that like how you have this the TV setup box will be there at the home, no? Similarly, if you have that kind of device at a home and you have a baby, whenever he cries, that will be automatically start blinking with a different color, saying that he's hungry or he has a irritation and he has a sleeping pattern or something like that. You know this, how much it will be easy for us. Correct?
Yes, sir.
Correct. So ultimately what it see that those are the real problems actually. So if you these are the AI techniques actually, still I don't see anything in the market, but this is always a patentable idea. Okay, getting my point?
Yeah, yes, sir.
Okay, you read my blogs, probably you'll get more knowledge there. Hmm? Okay. Okay, fine. Today I think this much is fine. Tomorrow we'll meet up.
Yeah, okay, sir.
Okay, fine. You're working, no?
No, sir.
No, no, I'm saying whatever I'm sharing the content with you, you are working, right?
Ah,
Yes,
I'm working, sir.
almost,
I'm working, sir.
yeah, because almost we have to be always hand in hand. Once this statistics is a very core part. Probably at the end, I will give one mini project or which you need to work on. After that, I will jump on to the machine learning.
Yeah, okay.
Okay, yeah. Okay then, huh? Okay, take care. Bye. Tomorrow we'll meet up.
Okay.